The function y equals arc sine of x or sine inverse of x, it's the inverse function of sine of x. So recall the graph of sine. We have a series of hills and valleys that repeat over and over. This graph oscillates up and down forever. In order for an inverse to be a function, the original function has to have a section cut off, and it's highlighted in red, such that the section passes both vertical and horizontal line tests. We need it to remain a function, but we also need it to be a one-to-one function. If we have a one-to-one function, then we will have an inverse that's also a function. So let's recall the domain of sine is all real numbers, and the range is -1 to +1. For the inverse function to be a function, we're going to restrict our graph to be 1-to-1, and again, that's the red portion that's highlighted. Typically, the graph is restricted from -π/2 to +π/2. Now, when we invert this red part of the graph, and we swap all the x and y coordinates, then we will have the graph of sine inverse x. So let's take a look at that. Sine of π/2 is equal to 1, so sine inverse of 1 is equal to π/2. Sine of -π/2 is -1, so sine inverse of -1 is -π/2. With an inverse, you're always going to be looking for an angle. So when we start doing inverse trig terms and expressions, we're going to be given a value from the domain in parentheses, and it'll be our job to report an angle from this interval, -π/2 to +π/2. The function arc cosine of x or cosine inverse, these two notations mean the same thing. They're just two different ways to write the same thing. It's the inverse function of our cosine curve. So remember, cosine shaped very much like sine, except at angle 0, we start at 1 instead of 0. Sine of 0 is 0. Cosine of 0 is 1. For cosine, we restrict this little piece from 0 to pi. From angle 0 to angle pi, this little red section is a one-to-one piece of the function. So when it's inverted, angle 0 and 1, angle pi and -1 will get inverted and swap out themselves. Now, like sine function, cosine has an infinite domain, and the range is also -1 to 1, because that's our minimum and maximum for the graph. If we swap all the angles and function values, then we're going to get the cosine inverse graph. Let's take a look at that. So recall that cosine of pi is equal to -1, and cosine of 0 is 1. So when you invert that, the way you want to read this is cosine inverse of -1 is pi. Cosine inverse of +1 is 0. For this inverse part, we're going to look at the domain as -1 to 1 and the range as 0 to pi. And then finally for tangent, remember tangent is a series of streaks that just repeat themselves every time you progress an angle of pi. It's easy for tangent just to take this middle streak, and it runs from -π/2 to +π/2. The domain of tangent all the way is all angles except the odd multiples of π/2. But if you limit yourself to -π/2 to +π/2, this middle strip, then you have a restricted domain from -π/2 to +π/2 in parentheses, because you don't count the vertical asymptote. The range is infinite because you can have a whole slew of tangent values based on what angle you take the tangent of. So for tangent inverse, if we take that middle strip from tangent and we invert it, we flip it over, turn it clockwise 90 degrees, we get our inverse function. Notice that the vertical asymptotes have now become the horizontal asymptotes, and the larger your angle gets, the closer to pi over 2 you get. The smaller, well, I said that wrong. The larger your x value gets, the closer your angle gets to pi over 2. You'll see this a lot in calculus too when you do integral tests. The smaller the x value that you put in here, the closer you get to the angle negative pi over 2. So for your tangent inverse, the domain becomes infinite and your range is restricted, whereas on the original graph, it's the opposite. When you're finding values of inverse trig expressions, you'll be given a value from the domain's interval, and you will need to provide the correct angle from the interval of the range. So let's use the unit circle to find the exact value of each expression. As we go through here, I'll remind you of the domain and range. For sine and cosine inverses, the domain is -1 to 1. The angle that you report is where you have to be careful. Okay, so at the bottom left of your screen, we have cosine inverse of 1. The way you interpret this is you're looking for the angle that has an x-coordinate of 1 from the unit circle. I highlighted this in red. 0 radians, if you look on your unit circle at 0 degrees or 0 radians, you will find an x-coordinate of 1. Cosine is tied to the x-coordinates. The middle example, we're looking for the angle that has an x-coordinate of -1/2. Now remember, the range for cosine inverse is 0 to pi, so you're only looking in the top 2 quadrants. The x-coordinate of -1/2 occurs up here at 120 degrees. If you look at your unit circle at 120 degrees, you'll find -1/2 as your x-coordinate. The radian measure is 2 pi over 3. And then finally, the example at the bottom right, the angle that has an x-coordinate of 0 from the top 2 quadrants is pi over 2. The ordered pair at pi over 2 is 0, 1, and so the x-coordinate there is 0. For sine inverse problems, the range is -pi over 2 all the way up to +pi over 2. So you're only allowed to look in the right 2 quadrants. If your angle happens to fall into quad 4, you'll have to backtrack it with a negative because the range is -pi over 2 to +pi over 2. It's a little tricky, and we're going to do one that handles that. The example at the bottom left of your screen, with sine inverse, you're looking for the angle that has a y-coordinate of 1. A y-coordinate of 1 occurs at the top of your unit circle at angle pi over 2. And so that's your sine inverse of 1. For the middle example, we have sine inverse of -1/2. So what you're trying to find out is the angle that has a y-coordinate of -1/2. On your unit circle, that shows up at 330 degrees or 11 pi over 6 radians. In order to give an answer that's in the range of sine inverse, we actually have to look at it through the eyes of that's a -30 degree angle in radians -pi over 6. The example at the bottom right of your screen, sine inverse of 0, we're looking for the angle that has a y-coordinate of 0, but you're only allowed to look in these 2 quadrants. Well, where the y-coordinate's 0 is here at angle 0, so theta is 0 radians. With tangent inverse, recall that the domain is all real numbers, but the range is negative pi over 2 to positive pi over 2, not inclusive, because at the very top or bottom, tangent's undefined. So I've got these little circles here that says we can look real close to positive 90, real close to negative 90, but we just can't be exactly 90 degrees or negative 90 degrees. In radians, that's pi over 2 and negative pi over 2. All right, let's look at the example at the bottom left. We are looking for the angle that has a y over x ratio of 1. Remember, tangent is the y coordinate divided by the x coordinate of your angle. So in order to have a y over x ratio of 1, the x and y coordinates have to be identical. Well, if you're only allowed to look in these two quadrants, the only place the x and y coordinates are identical is at 45 degrees, or pi over 4 radians. In the middle example, if your y over x divides out to a negative 1, then that means you've got the same number, but one of them's negative while the other's positive. That's a negative 45 degree angle. On your unit circle, it shows up as 7 pi over 4, but you have to look at it as negative pi over 4 in order for your answer to technically be in the range of tangent inverse. This range, that's where your answers have to be at the end. They have to be inside that interval. The example at the bottom right, tan inverse of square root of 3, we're looking for the angle that has a y over x ratio of square root of 3. Now that occurs at pi over 3, and let's look at why. At pi over 3, you have the coordinate 1/2 comma square root of 3 over 2. If you multiply, if you divide the y coordinate by the x coordinate, square root of 3 over 2 divided by 1/2 will give you square root of 3. Let's make sure that's true. The y coordinate at, and again, this is at pi over 3. You have the y coordinate divided by the x coordinate. That's a complex fraction, so you look at it as square root of 3 times 2 over 1. The 2's will cancel, and sure enough, that leaves you with a square root of 3. So sometimes it's a little difficult to figure out your tangent, but remember, it's always the y coordinate divided by the x coordinate, and that number in here needs to be the result of what you find over here. I hope this video has helped out. Reach out by phone or email. Give me a call if you need to, and I'll do my best to help you out. I'm going to erase some of this extra stuff. There we go. All right. I will see you in another video.